Okay, this question is asking for which molecule is not aromatic, and assume that all the rings are planar. So in order for a molecule to be aromatic, you must have, first of all, a cyclic planar array of p orbitals. That means a circle of uninterrupted p orbitals with no sp3 hybridized atoms between them. Second thing is the number of electrons in these p orbitals in the pi system, so it's in the ones that are in this array, have to be equal to this equation, 4n plus 2, where n is an integer. So, if we take a look at A, we have 3 rings. And when you have 3 rings instead of just 1, you need to draw different resonance structures until you can get all the pi bonds along the periphery. And so you can do that if you move these electrons here, these electrons here. That doesn't work. These electrons here, these electrons here, these electrons here, and these electrons here. And that doesn't work either. But this does. There. That's how to draw them. So you end up with that. Now if you look on this ring of p orbitals, they all have pi bonds. They all have a continuous system of p orbitals with each other, and then we count up the number of pi bonds. 1, 2, 3, 4, 5, 6, 7 pi bonds. 7 times 2 is 14 electrons. 4n plus 2 equals 14. 4n equals 12. N equals 3. 3 is an integer, so A is aromatic. B is quite a bit simpler. You just have 3 p orbitals. A carbocation, remember, is sp2 hybridized. It has an empty p orbital. And so you have 3 orbitals in a ring, and you have 2 electrons, because you just have the pi bond is 2. 4n plus 2 equals 2. N equals 0. 0 is an integer, so this is aromatic. Take a look at C. Again, we have another carbocation, but this one right here has 4 electrons. 4n plus 2 equals 4. 4n equals 2. N equals 1/2. 1/2 is not an integer. So this is not aromatic. And D. Have here is this carbon right here. That nitrogen's hybridization is sp2 hybridized because it's attached to carbons with pi bonds. So that lone pair is in a p. And so we count that lone pair as 2 electrons, and then 2 electrons for this pi bond, 2 electrons for this pi bond. That's 6 electrons. And 6 electrons is 4n plus 2, where n equals 1. That's an integer. You might be wondering why we don't count this lone pair off of that nitrogen. It's because that nitrogen is sp2 hybridized. But the difference between these two sp2 hybridized nitrogens is the lone pair is in an sp2 orbital. It's perpendicular to the p orbitals, so you don't count it. You only count the electrons that are in the pi system.